So thermal expansion, as you may know, metal, most solids, but metals in particular, expand when they get warmer and contract when they get colder. So that's very important in engineering. As you can see, this is a railroad in India where the tracks, the segments of the rail, the sections of the rail were laid too close together, so there was no room for expansion. The rail buckles, the train derails. Same in steel beam buildings. You have to take into account the expansion of the metals. The reason that metals expand is that metals, like any other material, are made out of atoms, and atoms get further away from each other when the temperature goes up. So this is a cold metal, and this is a hot metal. Cold, hot. You're smiling, but it's true. Now, you may wonder, this is actually the only thing I'm going to test, but you may wonder why they're getting further away from each other. Well, the reason is that what we call temperature has to do with the thermal motion of atoms. Atoms don't sit still, they shake back and forth, and the amplitude of that motion is what we call temperature. So this is these are cold atoms, these are hot atoms. Right? As you can imagine, if you move over a bigger amplitude, you need more space. So as they need more space, they move apart. It's an internal form of energy, if you want. Questions, anybody? I knew I gave very clear lectures. Look, it's not just those 9, right? Cold, hot. It's all of them, all millions of billions of atoms inside the material. No questions? Look, I'm not going to... See, one of the things I could do is make the screen black and then ask you the question, when metals heat up, they expand because the atoms A get closer together, B stay the same distance apart, C get further apart. But that would be simply me giving information to you and you regurgitating that same information back to me. I'm going to see if you have really understood this picture of atoms getting further apart and can transfer it to a new context. Are you ready? Yeah? No questions? Wow. Okay. So, here's the question. Consider a rectangular metal plate with a circular hole in it. Okay, and there's not going to be any talking, right? You first work on it individually. If you start talking, I run to you with the microphone and you're going to have to talk in front of everybody. All right? All right. When the plate is uniformly heated, the diameter of the hole, 1, increases. 2, stays the same. 3, decrease. What? 20 people have already answered. Have you thought about this? Please, think. Think about atoms getting further away from one another, okay? So take your time and then enter your answer. So let me tell you a little bit what we're going to do next. What I'm going to ask you to do, I'm going to give you a little bit more time in just a second, but I want you to turn to a neighbor and first say which answer you've given. And if your neighbor has given the same... Stop, wait a second, you get a chance in just a second. If your neighbor gave the same answer, you say, thank you very much, and you turn, to your other side, or front, or back. And if everybody around you has the same answer, you get up and walk around in the lecture hall. It's no problem. But you have to talk to somebody who has a different answer. Once you've convinced that person, or that person has convinced you, don't just sit there still, because I'm going to come right at you, right? Continue the game. Try to convince somebody else. So go ahead, find somebody else, and